Hi, my name is Allison, and I'm a PhD student at UNC Chapel Hill studying biomedical engineering. And what I really want to talk to you guys about today is magnets. They are just super cool, fun to play with, and a lot of people don't think about them at all. They're so common, people have them on their fridges, but they're really interesting objects.
Magnetic forces are one of the rare things on Earth that allow us to act on objects without actually touching them. You've probably played with a magnet before and know that they can attract or repel each other. Whether they attract or repel depends on whether I align the poles of the magnet to be opposite or the same as each other. So I've put some iron filings, a magnetic material, on a cutting board and can move them around with a magnet from underneath the cutting board. But why do the iron filings have this spiky pattern? They're aligning themselves with the magnetic field of the magnet. The magnetic field has a complex pattern in space. It's not uniform. So you can definitely see that it gets weaker the farther away from the magnet it is. This is an example of what the magnetic field along my bar magnet might look like, strong at the poles and along the axis and weaker elsewhere. To better visualize how magnetic field patterns can change in space, we can put the iron filings in water and look at the field between two magnets. So you can clearly see the field is strongest right along the center axis of the two magnets. Here's a drawing of what the magnetic field between the opposite attracting ends of magnets looks like. Did you know that there can also be magnetic fluids? They're really neat materials developed originally by NASA to help control liquids in space. They're called ferrofluids, and they look spiky like this under a magnetic force. Why does that happen? Well, the fluid is filled with tiny magnetic particles which align themselves with the magnetic field. But the surface tension of the liquid doesn't break, so the fluid gets pulled along with the magnetic material, kind of like this rubber glove stretching when something tries to push through it. So, what causes magnetic fields at all? Well, there are these tiny particles called electrons in the atoms of all materials, and all electrons also have a tiny magnetic force. But if electrons are in all materials, then why isn't everything magnetic? Well, there are lots of ways that magnetic forces can cancel each other out. If the electrons in an atom all line up so that their poles are opposite of each other, then all those magnetic forces cancel each other out. Then, even if all of the electrons in an atom manage to line up with each other, all of the atoms in different parts of a material don't have to make sure that their electrons are aligned with each other. They can be distributed randomly like this, and then the material still won't be magnetic. So in order to be magnetic, all of the electrons in each atom have to have their poles aligned, and then all of the atoms in different parts of the material also have to be aligned in the correct way. Otherwise, the material won't be magnetic. That turns out to be pretty hard to do, which is why everything isn't magnetic, and that's why magnets themselves are pretty special.